Okay, before I start here, my good friend Yuri Shaked is next door giving an amazing, I'm sure, talk. And I love Yuri. He's one of my very best friends, so I want to wish him luck. And I did wish him luck, but that was kind of lame. I think we could all wish Yuri some luck. So what we're going to do is I'm going to count to 3. We're going to open that door, and everybody's going to yell simultaneously, "Good luck, Yuri." All right, are you ready? 1, 2, 3. Good luck, Yuri! I'm sure he couldn't understand us, but that was good. Okay, if there happens to be a seat next to you, scoot in, make that seat available. I think we've only got a couple. All right. I just want to really briefly talk about myself. Hey, we're starting at like 3:10. Do you still want me to end right at 35? Yeah. From when I start or from when the clock starts? From now. All right. Well, I might end a little early anyway. Okay. Here we are. We're going to talk about Angular. Is that okay? Is that okay with everybody? Good. So, as he said, my name is Joe Eames. I organize a little tiny conference in the United States called ng-conf. Has anybody ever heard of ng-conf? All right. Hey. All right. Has anybody been to ng-conf? No? Oh, that breaks my heart. Well, we have to change that. Some of you need to come and visit ng-conf. The States are beautiful. It's a nice place. Not as much history is here. I went and visited the old city. It was like 4,000 years old. That's crazy. If we have buildings that are like 40 years old, we think, wow, that's old. I also am the creator of ng-doc.io. So that is a collection of community-created resources. All I've done is I've just gone out and found all the blogs and videos that people create, just like the video that will be produced from this talk, and collated them, organized them, and made them easy to search through and find. So if you're learning Angular, this is a great resource. This is the unofficial documentation for Angular, so check that out. And finally, I'm also an author for Pluralsight.com. That's what I generally do for most of my job, is author videos for them. I have a lot of videos on Angular available. So let's talk about dependency injection. A big question some people have, but certainly a good one to examine is, why do we even need dependency injection? But in order to start with that, we need to understand a problem. Right? So I'm going to present this talk as a series of problems with solutions. My first problem is, if I'm a component, I can't live in isolation. I need helpers. I need help, right? That help comes in the form of services. Services are how I, as a component, take an effect on other things. If we were to write everything that we needed into our one component, we would have some pretty crummy applications because they'd be hundreds or thousands of lines long. We don't want that. What we want is to modularize our code. So if I have a component, that component is going to need collaborators, helpers, right? So here we have a little bit of code where we have a login component. And that login component, I think I've got a little highlight right here. It deals with an auth object. That auth object has a login method. Very simple, straightforward code. The auth is actually what does the login. We don't want the component to actually be handling login. We want somebody else to handle that code. The component's job is to present, right? So we have this auth service. Well, how do we get a handle on that auth service, right? A very naive solution would be, we'll construct the auth service ourselves, right? We've got right here in our constructor for our login component, we're going to create a new auth service. And I'm going to do it myself. Well, there's a few problems with this. For one thing, we are now creating a unique instance of this service, or any services that we use, every time they are needed by a component, which for many services may not be a big deal. Like this particular example, the auth service, maybe we only use it in one place or in a couple of places, so creating a couple instances is no big deal. But what if we're using a service from some kind of a component that's in a repeater, right? In an ng4, and there are dozens or even hundreds of that components. We don't want hundreds of instances of a service generally. So that's a problem. The second problem is our construction logic is now embedded inside of our own code. Going back to this slide here, how to construct the auth service has to be embedded inside of this code. Next, this is not easily mockable. For testing purposes, it's not very easy, and there's also hidden dependencies. I want to talk about each of these in detail. So let's talk about unique instances. I kind of mentioned this, right? We've got to create a new instance for every one of our components. What about construction logic? So right here I've got some sample code where I'm creating a new users service and a new orders service. Now this construction logic isn't really difficult, but you can see I've already taken up a couple of lines of code, and at least I had to know how to new those up. These are nice simple ones, not such a big deal. But what if our construction logic is like this, right? We got to create a new users object. And the new users object needs an orders object. Well, that orders object needs a line items object and a discounts object. And then we also have to access the orders object ourselves, so we have to create up a new orders object and a new line items and a new discounts. We also see another issue here, right? The fact that the creation has to be time dependent. We want to create our orders actually before we create our users, because the users needs an orders object. So all of this, and these, again, these are just simple where, at least the bottom ones, they don't require any construction parameters. So even this is not terribly complex logic, but already we're getting into problems in our construction logic. Testing. By the way, I did some adjustments to my slides. I noticed that the bottom part of the screen isn't very visible, so I tried to move everything up. So you'll notice that things tend to shift to the top. That's not because I don't know where the top is, or I like to move things randomly around. I just did a lot of work moving things up. So please forgive me. All right, so here we have our testing. Here we have an order validator that constructs up its own orders object inside of its constructor. And then in the validate order method, it calls getOrder. Well, getOrder probably makes like an HTTP call. During testing, do we want to make HTTP calls? No, we don't want to do real things like that. So we really want to mock out this orders object, and specifically the getOrder function. Well, that's difficult when we construct the object ourselves. Right? To mock that out and to provide it with a fake orders object isn't easy. With JavaScript, it's a little bit easier because we can monkey patch, or as I like to call it, duck punching, but we can duck punch. If you're not familiar with monkey patching or duck punching, look it up. It's very interesting. So we can do those things, but they're still not very easy to do. And it's not really good practice. Finally, explicitly stating our collaborators. Right? When we inject all of the collaborators into the constructor, we have explicitly listed each one. Looking at this list, can you guys see, does this code look like good code to you? Anybody find any problems? Is there maybe an issue with this class, this do-it-all service class? I think there's potentially a little bit of an issue, and it's a code smell, right? We are indicated visually that there might be some kind of a problem because we're injecting, 15 services. That probably indicates that this do-it-all service is potentially doing a little bit too much, right? So that's another benefit of injection. If we can inject things into the constructor, we have a nice list of everything that our class uses, every collaborator that it has. But if we can construct our own collaborators anywhere we want, I was doing them in the constructor earlier on, but they don't have to be done in the constructor. They could be way down in the list. In the middle of a method, we might need a collaborator. If we construct it right there and utilize it, we have no indication that this class now has one more collaborator, right? The more collaborators our code has, the more complex it is. Here we have this nice little indicator that says after we get to 5, 6 collaborators, you might be doing something wrong. So those are all the problems with us constructing our own dependencies. Therefore, the real solution is not for us to construct our own dependencies, but to use dependency injection. So what does a dependency injector do? Well, it does two things. One, it constructs our dependencies for us, and we saw that that actually can be fairly complex, which dependencies to construct first, and how to inject them into each other before they are ready for us. And finally, it stores and provides those dependencies to us. All right, and this by itself is a big thing as well. Now, we ask ourselves the question, why do we want to do all of this? One, to move our construction logic to a more appropriate place. Two, to give us singleton instances, which is what we want generally. In most cases, a singleton instance is fine for a service. To help out with the dependency instantiation order, as we saw, we might want to create orders before users, to enable our testing, and to explicitly state our collaborators. Here's all the benefits of dependency injection. What is the implementation for a dependency injector? Very simple. It is always a key value store, sometimes called a name value store. In dependency injection, we actually often use the term token, and I'm going to use that term a lot. So where we see, here we have a list of keys, and once we ask for something with the key, the dependency injector gives us that thing back with a value. That's what a key value store really does, is we ask for something, it gives us the appropriate related item back. So I'm going to use the term tokens a lot because that's actually used a lot in dependency injection, specifically in Angular's dependency injection. So we're going to call it a token value store or maybe even a token instance store, but that's the implementation. So what about AngularJS's dependency injection, otherwise known as Angular version 1. What is its dependency injection system like and how is it implemented? Well, it was a key value store just like that. They actually use strings as keys. And for those of you who have used AngularJS and have done min-safing with annotations, you will have dealt with this because you had to create an array of strings, right? It's actually, I think it's really cool how AngularJS implemented its dependency injection. It actually took a function on toString that we can look at a little example of that here. I've got a little node. Oh, this is not very big. Let's make that bigger. Is that visible from the back of the room? You guys can see it? Okay. So if I create a function, do something, and inside of that function, we just have like a console.log. I actually want to create a function with parameters, so let's do this again. Do something, parameter, well, let's call this service one. This is how AngularJS worked, right? Console.log, service one.name, maybe. And then we close that up. We've got this function. Now we could take this function, and instead of invoking it, we can actually call toString on it. And when we do, you can see there that's actually a string, which is the text of the function itself. So AngularJS, what they did was they were able to extract the actual dependencies for either a service or a controller by toStringing the function and then using a simple regex to grab the list of the construction of the parameters to the function. So they would pull out that service one, and it would be a string, of course, and that would become the key in the key value store, and that's how they would look up things. So that's how AngularJS handled its dependencies. And how can I get my, now I've really hosed myself, I can't get my slides back. So we're going to play a little game of how do we get our slides back? There we go. All right. So it used strings as keys. The other thing AngularJS did is had a single global container, right? And I'm mentioning these two things specifically because they are actually problems that Angular itself solves, and we'll talk about those. All right, so let's talk about Angular's dependency injector, anything to and beyond. How does its dependency injector work? Well, first off, if you have done Angular, you will recognize code like this, right? In this constructor over here, I've got a private auth variable that is typed as an auth service. Now, you may not have spent a lot of time thinking about this, but you probably inherently understood this fairly quickly, and that is the auth service typing right there gives us a couple of benefits. One of which is it gives us tooling, right, a typing. Our tooling might give us IntelliSense when we type in the dot. The TypeScript compiler will warn us if we try to call a method that doesn't exist or a property that doesn't exist on that type, right? So we got the benefit of TypeScript's typing. There's another benefit that you probably, again, inherently understood, but haven't thought too much about, and that is dependency injection, right? If I want an auth service in my component to come in as a collaborator, as a dependency, I put it into the constructor just like this. And it's the auth service type that finds and gives me the right kind of thing. If I need an auth service and instead I inject an article service, I type it as article service, I don't get article service, even if I name it auth, right? It doesn't matter what I name the variable, it's whatever the type is. Well, what's actually going on is Angular is hijacking TypeScript's typing, okay? And it's the component decorator that does this. When Angular's compiler sees a class that's marked with the component decorator, or, and this may be, who here can tell me, there's a quiz, what is the one decorator that you must give every service? Injectable, right? And have you ever had a service that had no dependencies and you didn't put injectable on it? Did it still work? Yes. It does still work, yes. But as soon as it has dependencies, it doesn't work. Why? Because the compiler needs a clue that this is getting dependency injected. That's what that whole decorator is for, the injectable decorator is. So injectable or component, there's actually a couple of others, directive, for example, tells Angular compiler, hey, this class participates or wants dependencies potentially. So if there are any parameters on the constructor, then you need to go and look them up and provide them. And so at that point, it then inspects the class, and it doesn't do it with the toStringing that we were familiar with in the past. It's more complex than that, but this is all kind of like at compile time. So it can use better methods. And it asks for the type, and it uses that type to look it up in its dependency injection store. We call it a container, and find the right instance and give it to you. That's how this works. And so that's what injectable is for. So now, from now on, if you hadn't thought this through, you will now be able to answer not only does it need injectable, but why, and what's actually going on underneath the hood. All right. So provider registration. Now that we know that we have a service, and the service is stored in a key value store, right? So we create a service, and we want it to participate in the key value store. We need to register it. And since it's a key value store, we might think that we would do it like this. We would register it by giving it a key and a value, right? And that makes sense now that we realize that the type auth service is the key when we want to look up a service. It is actually the key. It just so happens it's also a way to get the value, right? Because the auth service type is not only our key, but it becomes the instance that we want. The Angular's dependency injection system news up a brand new instance of auth service for us. So we might register it this way. Now, we wouldn't register it by saying value of new auth service ourselves, because we don't want to construct it. We want the dependency injector to construct it. So we just give it the type for the value and say new this up. And we also give it the key. Now, they're the same thing, and why type the same thing in twice? So really, what we have is this nice shorthand syntax that we're all very used to if we have been doing Angular, which is when I want to register a new service, I simply give it the type, right? But underneath the hood, what's actually happening is it's being used for two purposes. So the type gets registered with the container. We do that on our module, and now it's available to all of our components. Well, what actually happens underneath the hood? Shorthand versus longhand. We're used to the shorthand. We were just talking about that. There really is a longhand that I was showing you, and if you haven't seen this before, this is how it works. Our key is this provide property, article service, and we give it a use class, which means what my service actually is a class. So please new up an instance of this class and make that available for anybody that needs that service. So that's what that's what we have. There's actually a lot more options than just use class. How many people here have done AngularJS? Quite a few. Okay, so we're familiar with, we had service and factory and value and constant, right? And we get to Angular and they say, don't have to worry about all those silly ways. We got one blessed way. Well, I'm about to burst your bubble. If you haven't had your bubble already burst, that's not true. they're just hiding all of the advanced ways from us. That's one thing that's great about Angular's dependency injector. It's this nice black box. If nobody shows up to this talk, nobody here has a problem doing Angular 2. We're just peeling back the covers so that we can understand a few things, and maybe we'll encounter some situations where this knowledge will be valuable to us. But the simple, all right, I create it, and then I just put it into my little providers list, and it works. It's all good. So we want to be able to choose a token. That's our first problem is, we want to use a non-class token, right? So I want to be able to choose my token. Look here, I've actually, on my provide, just given it a string. This is completely valid. I can give it a string instead of a class. The problem, though, is at that point, how do I ask for it, right? We're used to giving it the type, and the type is the key. We haven't thought about that maybe, but that is our type. So how do I ask for it? Well, that's where the inject decorator comes in. See right here, my inject decorator, I can give it the key explicitly. And now whatever key I'm using, that's the key it's going to use to look it up. And the type of the parameter, this auth service, no longer matters other than for TypeScript's purposes, for type checking. But it no longer matters for dependency injection if I give it the inject decorator. So now that I know these things, string keys have a problem. And that is if I use the same string key twice, I am now overriding myself, and that's what AngularJS's problem was. We didn't encounter it a lot, but it existed. If you used a third party that had a service that was named the same as your service, boom, you had a problem. Or you had to think through, I don't want to name this the same thing, right? Well, so object instances are much better because they're quality-based. So two object instances that have the same name are still two entirely different instances. And so that's what we use in Angular is an object instance. So they've provided for us an injection token. And that's this code right here. We're creating an injection token, and this is going to become our key. And it has three pieces to it: the injection token itself, the type, which is the type that the service matches. This isn't super important. It's just more informational for ourselves. And then a string that we pass in, again, not super important. This is used for like error handling. So those two other things are less worrisome. The point is we create the auth token, auth_token, and then when we register our service, then we pass in the auth token, and that is now our key. And we say use class, and it will new up a new instance of that. When we want to get an instance of our auth service, we can ask for it by that auth token. All of this probably seems very useless because the shorthand or the normal way is totally great. But what if I want to use a config object and have it be a service, maybe like my database info, right? I have a port number, I have a username and a password, I want to use all these, and I want this object to act as a service. Well, I can do that by registering it as a service and giving it a corresponding injection token, right? Because it's not a class. All right, the same thing works with global libraries. Say I want to use jQuery, right? Well, jQuery just gets stuck on the window. Well, I can use a token. I can create a token for jQuery, and then I can use a new, we haven't seen this before down there, it's not use class anymore, this is use value. It kind of corresponds to the .value function we had in AngularJS, right? I'm saying, hey, just grab the global jQuery object and make that a service, and the corresponding key is this JQ_token object that I've created. Next, what if I want to inject if I'm doing a migration, right? I'm migrating from AngularJS to Angular, and I want to use an AngularJS service as a service in some of my Angular code, right? My Angular 1 service in my Angular 2 or 4 code. I want to use that. Well, that's actually very possible. This is using the use factory. We've seen use class and use value. Now we're going to look at use factory. This looks a little complex. So I'll walk through it very quickly. Here, first we give it a provide, and we give it some kind of a key. In this case, I used a string, right? But we could have created a token. Then there's this deps, and that's the dependencies. So the ng upgrade gives us Angular 1's dependency injector itself, the actual injector, as a service that we can utilize. And so this is just the Angular 1 dependency injector. And then it's used right here, this I parameter. I'm creating a function here that takes in an I parameter. That's Angular 1's dependency injector. And I'm calling .get on that dependency injector, passing in the name of my service in Angular 1, right? And so now, use factory is basically for any time you need a function, and this is a good example of why you would need a function to construct a class. Use class I just said, hey, new this up for me. Use value, I'm saying, I've already got it, don't do anything, this is it. Use factory is, here's a function, execute that function, what comes out of it is what I want to be the service. So there's use factory. And finally, there's another option which I don't really have ever seen a good use case for, but they call it the alias service. And that is if I have one class, one service, and I want another service to act as that service, but not use a different instance. It's the use existing. Here's the syntax for it. Personally, I haven't seen a good use case for this, but it exists. All right. Finally, I want to talk about unique services. We are used to, it's all singletons, right? But occasionally, we could have a situation where we want a corresponding unique instance of a service for each instance of something. We want multiple instances. And a good example of that is a component level, well, the solution is for component level provider, but a good use case for this, sorry, let me put that aside. This is the solution, is to use component level providers in order to provide multiple instances. So you may not have known this, but on your component decorator, you can actually have a providers array, and you can give it services. That service is now available from that provider and from that component and any other child components that it has. They are now available to utilize that service. So there we go, we've created a user item state. So this might be for the case of I have a user item component, and I want each component to have its own unique instance of a state because this component is just getting so big, I want to hold the state in a service, right? There are other ways to solve this problem, but this is one way to solve that problem. So I want a unique user item state for each instance of my user item component. I can do it this way. And then whenever I ask for it, it's going to get that unique instance because it was declared on that component. So here's the example HTML for that. Let user of users. We're creating a user item, multiple of them. Each one has its own unique user, so we therefore want a unique instance of the user item service. Here's a nice visualization, right? I've got a user list. It has all these user item components. We want each component to have its own user state service, right? If that's the scenario we want, then component level providers are our solution. So we saw this before, right, where we have one container for everything. It's not actually true. Really, this is a much more accurate representation. Each component has its own dependency injector, and it uses basically like prototypal inheritance. So for example, if I have a module which has a user list component which contains a user item component, let's say that that also contains a username component. If the username component wants a user's service, which we see is declared up in the module, it'll ask its own container, do you have it? And it'll say no, and then it'll go up this list and say, does my parent have it? No. Does my parent have it? No. Does my parent, which is the module, have it? Yes. If the username asks for the user state object, it'll go up one level and say, does my parent have it? It'll say yes. The user item, on the other hand, when it wants a user state, it asks its own component, its own provider, dependency injector, and it says, yes, I do have a user state object, here it is. And it just so happens that my user state object is different from another instance of the user item component. It has its own instance. So I'm giving you my instance, or really your instance, and the other component gets its own. So, in summary, the dependency injector is actually a little bit deep, and there's a lot to it, but it's also very powerful. It's a great black box. You don't have to understand anything that I've told you in order to use Angular 2 in your typical case, but there are a few scenarios where understanding these things, it's just another hammer, right? The more tools that you have, the more finely tuned your code can be, finely crafted it can be. So there you go. That's my, this is all the information about Dependency Injector. Thank you for attending.